Hello children, welcome to Maverick Masters Academy. So in the previous session we have discussed how the reactions would be, what are the different types of reactions you see, and now today we shall get into the basics of chemical equations. That is what the chapter says, chemical equations. So what exactly is a chemical equation? We shall try to understand now. We have understood about chemical change and a chemical reaction. So yesterday in activity 1 we have discussed a reaction CaO, quicklime, reacting with water giving rise to calcium hydroxide. So this is the equation directly I have given you. But before writing this equation, if you don't know the formulas for this, we would have written like this, right? Calcium oxide reacting with water to give rise calcium hydroxide. But every time the reaction cannot be written in the form of these words. So we have introduced chemical formulas for each compound, which makes us easy to write this chemical equation. In the chemical equation, the left side of the equation always indicates reactants, whereas the right side of the arrow mark, right side of the equation indicates products. See here, as there is only one product, you have written directly. If there is one more product, you have to introduce plus sign between those products. As we have introduced plus sign between the reactants, as there are more than one reactant present. Now we shall get into this chemical equation in detail. You see here, you now know how to write a chemical equation provided if you know the formula of the compounds which are acting as reactants and the formulas of the products which are formed. Then you can write as a symbolic representation of that reaction. But is this the way? Is this all about chemical equation? No, there is something in detail you have to know about the chemical equation. If you observe here, you have introduced atoms. Calcium is an atom, oxygen is an atom, hydrogen is an atom. Individually, the compounds contain atoms in them. So these atoms must be balanced. If you count the number of atoms on the left hand side of each element must be equal to the number of atoms which are present on the right hand side of the equation. We shall start counting the number of atoms. If you see here, the number of atoms of calcium is 1. So how exactly I have told it as 1? If you see here CaO, if you consider the entire CaO, let me erase and let me write it in a clear manner before explaining this, such that you would understand clearly. Calcium oxide reacting with water gives rise to calcium hydroxide. Now you see, if there is nothing written in front of this calcium oxide, is there anything written in front of this calcium oxide? No, nothing. That indicates that there is one formula unit of calcium oxide. And here there is nothing written in front of this entire molecule. See, H2O is entire molecule, calcium oxide is entire molecule. If there is some number written in front of it, you have to consider that number. Let us suppose you have written 2NaCl. In activity 3 in the previous session, you have encountered this 2NaCl. If you see the equation, if you have the running notes, you go through that. 2NaCl, that indicates two formula units. Two formula units of sodium chloride. That itself says that two formula units of sodium chloride, in the sense 2 units of sodium atom, 2 units of chloride atom. That means 2 Na plus ions are present in this sodium chloride, 2 Na plus ions are present, 2 chloride ions are present. Combinedly, if two formula units of NaCl are said here, then 2 Na plus ions and 2 Cl minus ions are present. Like that, if it is written, if there is nothing written in front of a compound in a chemical equation, you would consider it as one formula unit. That says, if one formula unit of CaO means one calcium atom is present, I mean calcium ion, you can say Ca plus 2, and at the same time one oxygen atom is present. If one formula unit of CaO is taken, then see here, one calcium atom is present, one oxygen atom is present. At the same time, is there anything written in front of H2O? No, nothing is written. That itself indicates that it's one formula unit of H2O molecule. That says that, let me write clearly, one formula unit of H2O. This says one formula unit of H2O in the sense one H2 and one oxygen. Remember, one H2 in the sense, in this there will be two hydrogen atoms. Remember, one H2 molecule and one oxygen atom, when they are combined they form H2O. That says one formula unit of water molecule. In one formula unit of water molecule, if you see, one H2, one oxygen is present. That says two hydrogen atoms, one oxygen atom. Remember, one oxygen atom. Now you come here. Here calcium hydroxide is entirely one compound. So if nothing is written in front of calcium hydroxide, then you must understand that it is one formula unit of calcium hydroxide. One that says that one calcium ion. Same way here also you can write, I already told you, 1 minus 2, like this you can write. Okay, so one calcium ion, instead of writing that I am directly writing atoms. Okay, one calcium atom and one OH taken twice, right? That says that in one OH taken twice, two oxygens, two hydrogen atoms are present. Two hydrogen atoms, two oxygen atoms. Now we shall see the number of atoms on the left hand side of each element. Are they equal to the number of atoms on the right hand side? We shall see. One calcium atom is present over here. Shall we see on the right hand side? This is right hand side equation. One calcium atom is present. So calcium got balanced. One calcium atom on the left hand side, one calcium atom on the right hand side. Now you come here. Here one oxygen atom with CaO and one oxygen atom with water molecule. Then combinedly there are two oxygen molecules. Are there two oxygen molecules on the right hand side? Yeah. Oxygens are also balanced. Two oxygens are present. Here also two oxygens are present. So it is also balanced. Next you come here. We shall try to check with hydrogen. How many atoms are present? Two hydrogen atoms are present. You come on to the right hand side and just see. There are two hydrogen atoms on the right hand side also. So if you observe on the left hand side and on the right hand side, the number of atoms which we have written are equal. So this says that the equation is balanced. So the balancing of equation must happen. Why? It has to be ensured that the equation is balanced. We shall see. We shall try to understand why the equation has to be balanced condition, has to be in balanced condition. Because let us suppose if some magic has happened in this reaction, and if one calcium oxide is reacting with one hydrogen, one water molecule, and then it results in the formation of two calcium hydroxide ions. Let us suppose, I am supposing this condition, okay? It won't happen in a real life. I am just supposing the condition. If one calcium oxide one calcium oxide molecule is reacting with one water molecule to give two calcium hydroxide compounds. Is this really possible? No, it won't be possible, because if one calcium is able to generate two calcium atoms, then the entire universe, or else let us suppose wherever the reaction happens, the products will be less and the reactants would be less and the products formed will be more. So will this happen? No, not at all, because there exists a law in the nature which has to be abided by, that is law of conservation of mass. Remember, this law is very, very important. Law of conservation of mass. No new mass would be created anywhere. Remember, mass would be transferred it would get converted from one form to other form, but no new mass would be formed. Remember this. So law of conservation of mass says neither mass is created, neither mass is created nor destroyed. So this says that no new extra calcium or extra oxygen would be formed, and this not destroyed says that if you take one calcium oxide ion here, and here if the calcium gets disappeared, it won't also happen. If the calcium is taken on the reactant side, obviously on the product side there must be calcium. If the calcium is missing, that is not following the law of conservation of mass. Every reaction must follow this law of conservation of mass. So neither mass is created nor be destroyed. If something is taken on the left hand side, it must be present on the right hand side, but it might be in other form. It might be combined with other compound, but it won't be destroyed. No new mass would be formed, no mass would be destroyed. This is what law of conservation of mass says. According to this law of conservation of mass, the reaction must be in a balanced state always. Remember. So now we are going to learn a balancing chemical equation in a detailed manner, such that you can do balancing on your own. It's very, very easy. I am going to teach you two ways. You follow any other way. I will say which way would be preferable in an examination point of view, but I am going to teach you two ways to solve this law, balancing the chemical equations. Now we shall try to consider one reaction in example. It's there in your textbook. I'm going to consider the same example. You come up with some more examples. If you're finding any difficulty in solving these, you can ping me in the chat of the app. So I'm considering propane combustion. C3H8 is nothing but propane. When there are three carbons, you will get a root word called prop. Remember, you will get a root word called prop. Propane. propane. C3H8 is called as propane. When it gets combusted, see, combustion happens in the presence of oxygen. Remember, combustion always happens in the presence of oxygen. You see here, this is carbohydrate, hydrocarbons, or not carbohydrate, it's a hydrocarbon. C3H8 is a hydrocarbon. This hydrocarbon, when it gets combusted, remember, it forms CO2. Along with CO2, it forms water. Always any hydrocarbon under combustion, they form carbon dioxide and water. Now we shall try to see whether the written equation is balanced or not. So we shall see here, there is one formula unit of propane, right? That means one formula unit indicates one C3, one H8. That means three carbon atoms and one H8, in the sense 8 hydrogen atoms. So every time you need not take this formula unit concept while writing the number of atoms. So I am going to say this in a simpler way. See, remember, whenever there is something over here 3, you multiply this with coefficient which is present over here, the formula units, number of formula units which is present in front of the compound. Is there anything in front of the compound? No, 1. So what you do, 3 into 1. So there are 3 carbon atoms. If it is 2, let us write 2 propane molecules. If 2 is written in front of the propane, this 2 would be applicable for carbon, this 2 would be applicable for hydrogen also, because it is 2 formula unit of propane. Means 1 C3H8, 2 C3H8s are present. If something is written like this, then it means that there are 2 C3H8 molecules. Then totally 6 carbons, 16 hydrogens would be written. So remember, in order to write the number of carbons, what you do is you just multiply with the coefficient. If nothing is present as a coefficient, remember that the coefficient is 1. So 3 into 1. So totally 3 carbons. How many number of carbons are present? 3 carbons. While counting, you try to focus upon entire equation on the left hand side, because we are writing the number of atoms of an element on the entire left hand side. Left hand side, whatever the number of atoms are present on the left hand side, all those we have to consider over here. Okay, so totally 3 carbons are present. Hydrogens are 8 into 1. 8 hydrogens are present. Is there any hydrogens more? No. So I have considered only this compound. Now you come to oxygen. 2 into, is there anything written over here? No, nothing is written in front of the oxygen as a coefficient. So what you do, 2 into 1 would be written as 2. So this is how you would finalize the number of atoms. Now you come here, you try to write in the same order which you have written on the left hand side. That would be easy. Write in the same order which is written on the left hand side. CHO. We shall try to find out how many number of atoms of each element was present on the right hand side now. So carbon, how many carbons are present? You see here, yeah, here there is nothing written as the suffix. You see, there is nothing written as suffix. So when nothing is written as the suffix, then you consider it as 1. 1 into 1 would be 1. So you write 1 carbon. Is there any carbon more? No carbons are present. So you simply 1 multiplied by 1, you write 1 over here. Next, hydrogen. Try to see hydrogen. Is there any hydrogen over here? No. There is a hydrogen over this spot. Is there any coefficient present in front of water molecule? No. No coefficient was written in front of water molecule. Then what you do? 2 into 1. So you can write it as 2. Next, you come to oxygen. You see here, 2 into 1. Is there anything written over here? Nothing. 2 into 1 would be 2. Plus, here 1 into 1 would be 1. So totally, the oxygen count is 3. So you see here there are 3 carbon atoms. Here there is only 1 carbon atom. Here 8, here it is 2. Here it is 2. Here it is 3. So it's not at all balanced chemical equation. It is not at all a balanced chemical equation. Now we shall start balancing. See, while balancing, I am going to give you a tip. If you understand what is a metal, what is a non-metal in the equation, try to balance metal first, then non-metal. After that, hydrogen and oxygen must be balanced within the equation. So first of all, we shall see, other than hydrogen and oxygen, what is present over here? That is carbon, which is non-metal. So we shall try balancing carbon at first. Okay, so you have to write like this. Step 1, balancing carbon atom. Balancing carbon atom. Now you see, how would you balance? Here if there are 3, on the right hand also you must have 3, right? So what am I going to do is C3H8. See, on the left hand side, no need to alter anything, no need to change anything on the left hand side. Just put as it is, because you have to balance on the right hand side. So what are you going to do here? It is 1. So try to change. It's a start point. Never change coefficients of compound, balance to balance equation. Change coefficients of the compound to balance equation. This is a start point, remember. Never change the suffixes. Never change the suffixes. Coefficients matrame change alak. Suffix ante this suffix. This is suffix. If the coefficient, if you want to say, that is present in front of the compound, remember that. So you have to change the coefficient. This must be changed. If you want to change, this must be changed, not the suffix. Remember. So I want to make carbons as 3 carbon atoms. So I am putting 3 in front of the carbon dioxide molecule. Now you see, 1 into 3, the carbon atoms would become 3. So that is how I balanced carbon now. Try to follow here. So how many carbons are present? 3 carbons are present. 3 ones are 3. Hydrogens, 8 ones are 8. Oxygens, 2. Same order, I told you, always try to write the same order on the right hand side. As I have written CHO on the left hand side, try to write same on the right hand side. So here the carbons are 3. You try to see here, 1 into 3, the carbon number of carbon atoms would be 3 always. 3 over here. Next, hydrogens. You see, is there any change with the hydrogen? Is there any hydrogen in this carbon dioxide molecule? No, there is no hydrogen in this carbon dioxide molecule. So I am going to consider this 2 ones are 2. That's all. Next, come here in the oxygen. If you see, there is some alteration. 2 3 just 6 plus 1. So totally oxygens are 7. Here there are 6. Here there is only 1 oxygen. So 6 plus 1, totally the oxygen count rises up to 7. So is it balanced? Carbons are balanced, but hydrogens and oxygens, they are not balanced. If you are considering 8 hydrogens on the reactant side, if 2 hydrogens are produced on the product side, will that be okay with the law of conservation of mass? No, law of conservation of mass won't accept this happening. 8 hydrogens are present on the reactants, then surely 8 hydrogens must present on the right hand side also, on the product side also. So we shall try to balance this equation further. So by writing the second step, see, I have written this first step and I am going to do second step balancing. Remember, I am going to do second step balancing over here. Step 2. Step 2. Balancing. See, remember, I always follow this simple technique. When oxygen, here oxygen is 2, here oxygen is 7. Here it is even, here it is odd. So I am not going to balance this oxygen at first. I told you, after balancing carbon, you can balance hydrogen or oxygen, whatever you wanted. Hydrogen and oxygen must be balanced at last. This is what I have told you, right? But here you see, oxygens are present in odd and even conditions. So I am not going to touch that, because you can do it, but instead of doing odd and even balancing, try to balance whichever are in the same condition, like in even condition 8 and 2. So we shall balance hydrogen at first. Balancing hydrogen atom. Now you see how many hydrogens are present here? 8. So how many hydrogens must present over this side? It must be 8. So how can we make hydrogens? 8 hydrogens. See, you have to rewrite all these. I'm just erasing on my own. Simple. This equation I have written same, C3H8 plus O2, C3H8 plus O2 giving rise to 3CO2 plus you need 8 hydrogens on the product side, right? So what am I doing is I am putting 4 into 2, 8 hydrogens. Is it 8 hydrogens now? Yeah, it makes 8 hydrogens. So carbons are 3, here also carbons are 3. So if you see here, hydrogens are here 8 and here the hydrogens are 2 4s are 8. 8 hydrogens are present. Oxygens, how many oxygens are present? Here 2 oxygens are present, and 2 oxygens are present. Over here 2 3 are 6 and 1 4s are 4. So totally 10 oxygens are present. So now if you observe, carbons are balanced now. In the step 2, carbons and hydrogens are balanced. Oxygen is unbalanced, so I am balancing oxygen now. Try to balance it. It's very very easy. In step 3, balancing oxygen atom. Now you see C3H8 plus, you see here on the product side there are 10 oxygens, right? But on the reactant side there are only 2 oxygens, right? By putting 5 as a coefficient. 5 as a coefficient, 2 5s are 10, right? So you are making oxygens as 10. So now you see 3CO2 plus 4H2O. Now you try to write the count of each atom. Carbons are 3, hydrogens are 8, oxygens are 10. Again you come here, carbons are 3, 1 3s are 3. Next hydrogen, see same order you have to write. Hydrogens are 2 4s are 8, oxygens 2 3 are 6, 1 4s are 4, 6 plus 4 10. You see carbons are balanced, hydrogens are balanced, oxygens are balanced. So this equation which we have written over here, this is balanced chemical equation. So this is the methodology you have to follow when you are writing in a examination. If something is asked for 2 marks, you have to write these steps. If something is questioned for 1 mark, directly you can balance the equation, you can write the balanced chemical equation. No need to write all these steps if it is asked for 1 mark. If it is asked for 2 marks, you have to write all these steps and you have to ensure everything is clear to get those 2 marks. And I am going to teach you the second methodology in the next class. Till then, bye bye.